Okay, so now we are going to do some transformations on the sine and the cosine. So just to be clear, we're looking at first the sine. So you should know that the sine function starts right on the origin. There's the four quadrants, right? And quickly, when you start here, you go then to 1 and -1. -1 to 1 is the range. And then you go back down to -1. So this is what your function looks like. I missed the dot a little bit, but you get the picture. Okay, so cosine looks a little bit different. All right, so if we have 1 and -1, sine and cosine look the same, except they're really transformed, shifted a little bit. So we start cosine at 1, and then we have our four quadrants, and it goes down to 0, then down to -1, back up to 0, and then up to +1. So the cosine curve looks like that. So that's just the general form that we look at. So now we're going to look at some transformations. So first, the graph here is the cosine. You can see that it starts at 1, and then it goes down to 0, and then -1 and 1 at 0, and then back up to +1, and then in reverse. Okay, so this is the cosine curve. Now we're going to take a look at what happens when you put a 4 in front of it. Now, in order to do this on your calculator, you're going to make sure you're in radian mode. Okay, so go ahead and hit the mode button and make sure you're in radians rather than degrees. Okay, then you're going to go into y equals, and you're going to hit 4 cosine x, and then you're going to hit the zoom button, and option number 7 is trig. And then you'll be able to see what the graph looks like. Okay, so you can see that your graph is broken up into those quadrants. So you can see that at 0, when x equals 0, y is equal to 4. 1, 2, 3, 4. So now we're up here. And then it's still at 0. And then here it's at -4. So you can just follow the graph, and you can see what your graph is going to look like. Okay, and then it's the same thing on the other side. Okay, so this is y equals 4 cosine of x. So what happened? Okay, how can you describe that? Well, that vertically stretched it, right? It's a vertical stretch. And you can remember from transformations back a few units ago that that's what it is. When you have a number in front of a function, okay, such as y equals c times f of x, that c value stretches it or compresses it depending on whether it is greater than 1 or less than 1. Okay, so now let's try -3. Go ahead and type that into your calculator and look at the graph, and you can see the difference. Okay, so now I always start at 0. So when x equals 0, I'm down at -3. And then I'm up at 0 again. So I'm just looking at each of the 4 tick marks on my calculator and seeing where am I for all of those tick marks. And this is what it looks like in both directions. Now notice how I graph. I graph by placing the points first and then tracing the graph. So you want to make sure so that you're exact. that you are going through those points. So you want to make sure you graph the points first. So y equals -3 cosine of x. So that 3 still vertically stretched it. But what did that negative do? Same thing when you put a negative in front of f of x, right? It flips it upside down. Okay, so it reflects it over the x-axis. So notice that the negative cosine, it starts down below the x-axis, and then it goes in an upward direction first instead of starting above the x-axis and going down. Okay, so as we can see, this coefficient controls the stretch that the cosine curve rises and falls above the x-axis. Or you can say the height that the cosine curve rises and falls above the x-axis. Its absolute value is given the name amplitude. So this value is so important that it's given its own name, and that's called the amplitude. So in terms of sound waves, it indicates the volume of the sound. So now we're going to go down and do this without a calculator, and this time we're going to use the sine curve. So we have this is the sine of x. Okay, notice that the range goes from 1 to -1. Okay, but now we put a 3 in front of it. So what does that 3 do? It stretches it. Okay, it represents the height of the curve. Okay, so I'm going to start at the origin, right? Because that's where sine starts. And if you're going 3 times as far away from the x-axis, that's how we stretched before. Then when you're on the x-axis, you can't get any farther or closer to it because you're right on it. But here at pi over 2, right, it's at 1. So now I'm going to go up to 3. And 0 stays at 0. -1, 3 times -1 is -3, and then back to 0. And the same thing on this side. So you don't actually need a calculator to do this once you understand what is happening with these curves and with what kind of transformations are going on. Okay. Now let's try the negative sign. Okay, so now we're still going to start at 0, 0, right? Because negative reflecting over the x-axis, you can't reflect over it when it's on the line. But now at 1, it's going to go to -1 instead. And then at -1, it goes up to +1. And you're going to do the same thing here. So it turns out that you're just flipping this upside down. Oops. There you go. And that is negative sine of x. So you're just flipping it upside down. So the amplitude is half the difference between the maximum and the minimum. So for example, I'm given this graph. Okay, if I'm asked what is the amplitude, right, I'm going to look at, well, the top, the height is at 5, the highest point. The minimum is down at 1. So the amplitude is half the distance between the two. Okay, that would be considered the height of the curve. Okay, so 5 minus 1 is 4, and that divided by 2 is 2. So the amplitude is 2 here. So I know that part of my equation is going to start with a 2. And then we're going to have the trig function, which in this case, it's the sine. And I'm going to show you how to figure that out later. And there's also going to be some other shenanigans going on here, okay, which we're going to learn about. So go ahead and do the practice now.